As promised, on Thursday we talked about adding functions to objects and kind of using them, using them within the definitions of the object. And then we're going to dive a lot more into functions today, or rather for the next two lessons, both this morning and this afternoon. Um, so functions, like we said before, everything in JavaScript essentially boils down to an object, but especially functions, right? Functions are just like objects in the sense that we use them like objects, right? They can be created, they can be modified. They can also be passed back and forth like we do anything else, right? We can send them from one place to another. And so being able to use functions very, very fluidly or very comfortably is very important in JavaScript or in programming in general, because once again, the point of programming is to write efficient code, which means if you write a function that does something, you don't ever want to write that function ever again anywhere else. You just want to pass this function so that someone else or somewhere else we can use it again. So the whole thesis of this morning is that last bullet point, right? Which is that like in the same way that we currently pass numbers, pass booleans, pass strings from one function to another, into a function to be used as parameters, etc. We can do that with other functions as well. Because once again, functions are just a data type like everything else. Okay. So in this case, nothing too groundbreaking, right? We have an empty array, we have a string, and we basically push the string 3 times into the array. In this case, now that we know on lines 7 through 9, when we say push and we pass in happy string, we're actually passing in a string, right? Which is a primitive, which means when I log out amazing array on line 11 there, I have 3 versions of this happy string, but they're copies of the original string, right? They have no ties to the original happy string that was defined on line 5 there. But this is how we normally push something into an array. So because, like we said, functions are very similar in terms of kind of how we pass them back and forth, if I now define a function called happy function and I push happy function into the amazing array, I now get something like that. Just note, the function in the brackets, like for each individual element, these brackets they have no correspondence to the idea of an array. It's just how JavaScript prints out arrays. So don't read too much into that. These outer brackets are arrays because we created it on line 3 there. But the brackets surrounding the word function, they're not arrays, so to speak. The other thing here to note is that we define happy function on line 5. Notice how on line 9 there, when we push happy function in, right? We're not invoking happy function, right? At that point, happy function could be anything. It could be a string, a boolean, a function, whatever it is. There's no open and closed parentheses after happy function, so we're not invoking happy function on lines 9 through 11. So therefore, when I look at the array, it doesn't give me what happy function returns. It's just literally, here is happy function. And it happens to be a type called function. Yeah. Is that your question? Or, yeah. Yeah, so this looks weird, but this is totally valid. And if we kind of go a little bit further now, so line 8 basically is a shortcut to create what we created on the last slide. Okay. So after line 8, if we look at lines 10 through 13, now what we're doing that's pretty interesting is now, whereas before we literally just pushed the raw function into the array, on line 10 we're saying, all right, let's go through that list of that array of functions. On line 11 we extract out each individual function, and on line 12, notice now we're actually running it, right? Even though element is it's a different name than happy function, element on line 11, element is equal to amazing array, right? Amazing array index I, sorry, right? And because functions are complex data types, or rather non-primitive data types, right? Like this is the reference to the original function, right? These are not copies of the other function. So now when I look at this, when I say element is equal to amazing array, element is equal to this function, when I invoke element, it's the same as me invoking this function. And so that's why on line 12 there, when I invoke element, I'm actually doing it 3 times because it's a for loop on line 10. So I'm going through every single element in the array. And for every single element, I'm invoking it. I'm assuming that every element in here is invocable. And if I can't invoke it, JavaScript will throw an error at me saying, element is not a function, right? But because it is, I print out I am happy three times to the screen. So even though now I've basically kind of come full circle, right? I can pass a function as a normal variable into an array, and now I can also use it as a function or use it through a normal variable. So therefore, functions really are just treated like any other normal variable in JavaScript. We can pass them back and forth. We can use them through variables. Any questions here? Cool. Okay. Too fast. Okay. If I was to pass something like this is pretty straightforward, right? Like this page basically we have a function called logs the type. I pass in a value and it tells me what the type of the value is, right? Because if I pass in a string, it will give me back a string. If I was to pass a function into a function, well, no surprise, right? A function type is a function. And so in this case, for type of, it actually works really well for us to determine if something is a function. And if you're ever in doubt about whether or not something can be run, just do a type of kind of comparison first. The other thing is that on line 4 there in that comment, so the name of this particular lecture is called higher order functions. And basically what we say that to mean that it's a function, like we call functions that either take in a function or return a function higher order functions, because it's like the function that's going to be used is like kind of the lower order function, and then this other function is almost like a transport or like a mechanism for delivering that original function. So it's like a higher level. Probably not the best naming, quite honestly, but just know that like when I say higher order functions, they are just like normal functions, except they happen to either take in or give back another function. So it's more of a semantic thing than any kind of computer functional thing. Okay. Yep. So now this calls a function is essentially a higher order function, right? Because calls a function on line 3 there, it takes in a function, a parameter called another function, and on line 4 it invokes that another function. So this is just kind of, it's very similar to two slides ago conceptually, but it's just now we can put a name to the calls of function because it's called a higher order function. Usually it's kind of used more communicatively. So if I say like, oh, I wrote a higher order function, people know that like it means like I'm playing around with other functions. Is it?
When this happens, is it like JavaScript or the computer is saying let another function equal happy function?
Yeah. So if this code was to run between line 3 and line 4, we're basically creating a variable called like another function, like let another function equals, and it equals whatever is being passed in. So it'll be let another function equals happy function. It's just like how normally like the parameters get created when we pass in strings and booleans. This is the same exact thing that happens here. Okay. Cool. All right. Cool. So if we look at like these examples of or rather if we look at these code examples, we have two functions there on lines 1 through 3 and 5 through 7, right? Says hi and says bye. In both cases, they take in a name and they just console log something out. However, on line where is it? Oh shoot, sorry, that's a typo. Let me correct that really quick. Sorry guys. Okay. Here, so on line 9, so I have these two kind of like smaller functions that does one very simple thing, and then I have this higher order function on line 9 that basically expects to take in a name and a callback. A callback function is something that it's another name. It's kind of like, whereas a higher order function is like the function that's like either taking in or somehow redistributing another function. A callback function is a function that's passed in that's meant to be called. So do you remember how like 2 days ago we were doing that one problem where we had an object with 10 different functions, and the idea was, hey, let's call all 10 of these functions with that one thing that I passed in. That's basically like a simpler extension of this principle, rather more complex extension of this principle, right? Which is basically saying like, hey, a lot of times one function is expecting to take in an argument, another function, and its job is to take those things together and call the function with that argument. So here on line 13, we want to look at how we're invoking calls with name. On line 13 for calls with name, we're taking the first argument is a string called Sadie, and the second argument is a function called says hi. Notice how says hi has no open and closed parentheses, right? So says hi is being literally passed in as a function. It's never being run, it's just being passed in. Once we pass it in, on line 9 there, name becomes Sadie and callback becomes says hi. And then we invoke callback, and those open and closed parentheses here. Then we invoke the callback function and we pass a name, which is Sadie, which is why we get hi Sadie, and then subsequently beneath it by Sadie, right? So just kind of mentally be aware that like even like functions are just like normal variables, but within the parameters of a function, if I'm taking a bunch of things in, everything gets renamed to the parameter, right? So don't be intimidated by this callback. Like literally, this is just a variable, and it happens to represent the second argument of whoever called it. In this case, the second argument is a function, so therefore I can invoke callback like I would be invoking that function. Okay, callback is once again a semantic thing. It has no bearing on like the abilities or the operations of the function itself. It's just how we talk about things to distinguish it from other functions. Okay. Any questions so far on functions? Yeah, Dimitri?
Can I actually, instead of callback, like declare a function there and write the code for that function right there?
You could. You could. But once again, like, it's just like a matter of like, if I declare the function within that function, I can only use it within that function.
Yeah.
Right? So the point is like, if I have somewhere else where I also want to use says hi, I can't define it in there because then scope basically limits me from using it anywhere else that's outside of that particular scope. Right? Okay, cool. All right. Okay. And then this is very similar here. Not too different. On line 1 through 3, we define a function called addWorlds. On line 5, it's called calls with hello. It basically takes in a function and it invokes that function with the string hello, right? So it's kind of hard coded there. We're always invoking whatever it is with hello. On line 9, we call calls with hello. We pass in addWorld. But notice how we also capture the output of calls with hello in this variable called result, right? In the previous slide here, notice how we never return anything, and so therefore we don't really need to we don't need to worry about capturing the output. We just run calls with Sadie and calls with name twice, and what we care about is what the console log or what logs out. On the following slide, this is a lot more common. Usually we do care about what's being returned, right? And so if we look at calls with hello, what does calls with hello return? Well, it invokes the function, it passes in hello, and then it returns whatever that returns, right? So you can think of it as like a return chain. So now the question becomes, what does func invoked with hello returns? Well, func is the addWorld string, and what happens when we invoke addWorld with the string hello? It returns hello plus world, so it returns hello world. So it returns hello world to calls with hello, and then hello world's going to and then calls with hello is going to return the hello world to calls with hello on line 9 there. So therefore, result becomes hello world. Everyone see that? Yeah, Amir.
Isn't the return being invoked twice then? In this case?
Yep. Yeah. So basically, like you can think of the return operation for a function as saying, I will return this to whoever asked for it, right? And to a function, whoever asks for it is whoever invokes it.
Yeah,
So yeah.
So like, what if you don't do the return on that second? It says function calls with hello.
On line 6.
Yeah. So what if you didn't do the return there, but it still returned something?
No. Well, calls with hello will not return anything then, right? Because there's no return.
Yeah, but if you give it the function addWorld, there's a return within that, right?
You got rid of let result equals, right? Is that what you're saying?
No, I think he's basically saying, what if this return was not there, right?
Yeah, and you gave it the addWorld. Wouldn't
Yep.
it still return hello world?
Right. So basically, like, think of it this way, right? Like, this is asking, hey, like on line 9, line 9 in specific, this result variable is asking, what does this return, right? Over here, so basically like this is going to say, all right, okay, if a function returns whatever it's supposed to return to whoever is asking for it, calls with hello is executing func, right? So this line 6 is asking this function, hey, what do you return? And the answer is hello world, right? Like this eventually becomes hello world, right? But once we get there, like this return is meant to answer whoever's asking for add world, right? This is asking for whoever returns from calls with hello. And if you have no return for calls with hello, it's not going to return the string organically. The caveat there is that in all JavaScript functions, if you don't give it a return thing, if you don't say return this, by default it returns undefined. So basically after line 9 runs, it will equal undefined, right? But the return only works to the immediate ask, right? That analogy time, right? Like if your boss asks you for something, or rather, if your boss's boss asks your boss for something, and then your boss asks you for something, you can give it to your boss. It doesn't mean your boss is going to give it to his or her boss, right? So unless like that chain is very linear and very direct, like your work will not be passed all the way up. If there's no return in the middle there, it's going to break. Yeah, so the return only works up to one level, just in a way of speaking. Okay, all right. We log out the results. We get hello world. Okay. I mean, I think at this point we're kind of getting a little bit redundant with some of the slides in terms of like we just really want to kind of beat this idea into you that like functions are just like normal variables and we use them just like normal variables do, right? So here's kind of a more like, oh, like this is another example of how something could work. Let's say I have a list of people under in this case under line 7 there, the group variable. I have a list of names, right? And I have this function, this higher order function on line 9. Or rather, I have this higher order function on line 1 that says, hey, I have this function, take in something called names, and take in func, right? And what I'll do is I'll go through every single name in that list, and I'll call func with that name, right? And so if this is func down here, all I gotta do is now we can see kind of how like higher order functions are really useful, right? If I ever want to say hi to one more person, well, I don't need to rewrite a lot of things. All I got to do is keep adding an extra name to this array, and as long as I'm passing it in on line 13, group and this func will be passed into say to all, and then say to all will automatically iterate on my behalf over that list. So, and this is actually like a very like kind of core engineering principle, which is the idea that like you want your code to be easy to use. And easy to use means if someone wants to change this code to do something else, they should only be touching the parts of the code that they're actually trying to change, right? So in this case, if I want to say hi to 10 more people, all I really want to do is give you 10 more names, right? I don't want to have to rewrite your for loop for you. I don't want to have to rewrite your function for you. I don't want to have to rewrite anything else besides just saying, here are 10 more strings. Could you say hi to them, right? So when you write your code, you also want the entranceway. You also want your code to be accessible in a way that says, oh, great. All I got to do is add some more names to this group array. Everything else will take care of itself, right? You want the future users to do as little as possible. So this is like a very, very kind of common pattern for writing kind of higher quality code. Great. And then this is just to note that I guess maybe this might be Dimitri's question or not. So far, we've kind of created all these functions with variable names, but we can also easily put anonymous functions there too, right? Anonymous means we just define it on the spot. So it might look a little bit weird to you right now, but on line 11, this is a function called say to all. We define up here. We take in 2 arguments. The first argument is still group, which is an array. The second argument is a function that we're just defining on the spot, right? So everything between this function keyword up until this curly brace is just one thing. It's the second argument to the say to all function. Is there a question, Greg?
Is there any reason to do one over the other?
I mean, usually the rule of thumb is if you want to anonymous functions serve some purpose. Usually it's kind of more of like if you're ever going to use a function only once, like there's no point in kind of storing it somewhere when you don't need to store it.
So
But there's also nothing wrong with always using variable names for functions. So it's up to you. Like it's not wrong. It's just like does it work for what you're trying to do? Like this afternoon when we talk about array methods, you'll see a lot more examples of like functions that we're only using kind of one time, and so there's just less need to like create a variable, store it, use it only once, and then it's like because creating a variable does take up a memory in a computer anyway. So it's like why create like 20 variables that you'll never use ever again past that one point. But I mean, it's like a very small nuanced detail. Like, doesn't really matter. This is more like if you see that in the wild, don't get scared. Like, that's just all that is.
Yeah.
And once again, for everyone's benefit, the function is called anonymous because once again, notice there's no name next to the function, right? Like on line 3 there, we have function say to all. On the line 11, it's just function and takes in one argument, which is name. That's pretty much it. Like anonymous functions, as the name indicates, basically means they're nameless, which also means they're not really reusable. Like once you define an anonymous function, you can pass it in somewhere, but after that you kind of lose access to it. Cool. All right, last couple slides here. Okay, calc. Same idea, right? We have two functions, line 1 and line 5. One's called plus, one's called minus. Notice how now we're returning things. Notice also on line 9 there, we have this function called calc, right? And it has to return whatever the operation func, basically whatever function gets passed to it returns, right? Because once again, if we think about that level of hierarchy, like a function will only return whatever it has to whoever's calling it. It's not going to return past that, right? And so every single person needs to be responsible for returning or kind of handing in the work. So on line 13 there, if we look at the console log, what we're doing is we're calling calc, we're passing in 10 as num1, plus becomes the operation function, and then 20 becomes num2. And then on line 14, we do the same thing, except now we're using the minus operation. In all cases now, we have 30 and 40. Like the reason why like something like the higher order function like calc is really like helpful here is notice that we could also just write a function called like multiplication, right, or division, and we could easily just like slot it in there. We don't need to do any more work, right? It's just a times b or a divided by or num1 divided by num2 or num1 multiplied by num2, and so calc becomes a function that's known as very extensible, which means we can build a lot of things on top of it pretty easily. So yeah. And then the last thing is for each, and then this will lead us into the afternoon lecture on array methods. But a quick thing for each is, I guess it's a little too late now, but a function passing another function is often called a callback. For each is something called an array method. So one of the things we didn't talk about when we talked about the array was, or rather, one of the things that we alluded to was like arrays are really powerful because they have a bunch of nice nifty tools are built in, right? We looked at some of them like index of and dot reverse, dot shift, dot pop, whatever, and they're nice. But really, one of the things about arrays that makes them really powerful is a lot of times you want to do something to every single element in your array, right? It can be something as simple as send all of them in an email, or check every single item in this list. And so far, we've been able to do that by writing for loops. But if you notice how cumbersome writing a for loop is, and given how lazy developers are, like we also figure out some ways to just make that a lot easier too. So we call those kind of built-in array methods. One of them is called for each. And what the for each method does is the for each method takes in a function, and it basically calls that function with every single element in the array, right? So if I have an array of 10 names, and if I take in a function, what Java's going to do for me is it will invoke that function with each name individually 10 times. So it will run that function for me 10 times. So let's take a look at how it's used here, right? So here I have an array of bridges with 3 items. I have a function that's called log uppercase, and what it does is it takes in a string and it console logs that string, but capitalized. If I just do bridges.for each and I pass in that function, ta-da! Notice how on line 7 there, when I pass in log uppercase, I never invoke log uppercase. In fact, nowhere on this page am I ever invoking log uppercase, right? And the reason for that is because for each is doing it for me behind the scenes. For each is a shortcut, and so it's going to take certain liberties for you. We can easily rewrite this without using for each. Right? We just do, for let I equal 0, I is less than bridges.length I plus plus, and we'll go through the bridges array and print out, and explicitly call log uppercase for every single bridge in that list. But on line 7, it's just shorter. It's a little bit easier, right? And so what line 7 does is it just takes in a function. You don't see it calling it, but it is calling it on your behalf. And what it'll do is it will call that function one time for every single element in your array, and it will pass in that element as the only I believe the only argument to that array. It may be passing more stuff, but for now, let's say it will pass in at least the first argument in the array, right? So if I wanted to say, hey, only log out for me, only log out for me, every other item in the array, then for each might not be the best tool for you to use. There is like a janky way for you to do it where you can get around it, but it's like at that point you might as well just write a for loop, right? Like this is kind of like I'm blanking on what it was we talked about earlier, but it's like this is a shortcut, which means it takes away a lot of the details for you, but it also means you kind of have less fine control over every single aspect. So this is meant to be a shortcut for the for loop. It does not replace the for loop. If you want to use it, go ahead, and you will for the workshop today. But this will build on top of other array methods that we'll talk about this afternoon that are a bit more powerful. Oh, I lied to you. It passes in a few things. The first argument is the element. The second argument is going to be the index. And let me just double check to make sure I'm not telling you anything else that's not true. JavaScript for each. If I just Google this, I go to Mozilla. Let's see what the for each method is. Okay, so this, it looks like what the for each method will do is it will call your function and will pass in several arguments. The first one is the element itself, and that's a non-negotiable. It will always do that for you. The second element it will pass for you is the index of the element, and the third thing it will pass for you into the function for you is the entire array itself. Now, just because it passes in 3 things to you doesn't mean your function needs to take in all 3 things, right? If your function is built so that it only accepts one argument, then only the first one is going to be accepted, which in this case is the element. And so that's why, if I go back to the slide here, on the previous slide, notice how log uppercase only takes in one argument, which we call string. That means for each is invoking log uppercase with the element, with the index, and with the array itself. But our function says, I don't care about the other 2 things. I just want the first thing, which I know has to be the element. And therefore, it does that. In the second case here, it looks like what we're doing is now our function is now our callback function on line 7 there is equipped to take in 2 arguments. One's the element and one's the index, right? So we're still ignoring that third argument of the array. But it's totally fine, right? Like it can give it to us, we just won't use it. It's the same as us accepting it in the function, never using it. So yeah. So that's like a not crash course, I guess, but that's like an introduction to kind of higher order functions. And then we'll talk more about array methods this afternoon. Any questions? It is a lot.
Within for each, could you use an anonymous function where the parameter, like in for each, where you pass in a function, the parameters, can you declare an anonymous function there as well?
Yeah, totally. Yeah, I mean, let's just I'll write this down and then I'll share it with you guys on a repo. Uh-oh. Is everyone's internet still working?
Yeah.
So it's just me, or is repo down?
It's working.
Okay. Oh, right. Sorry. Repo server is down. Okay. Never mind. Let's just write it in Slack then. Oh, okay, great, it's back. Okay, so this is the code that was on the slide. If I was to write, so I'll say this is, for each, and then if I'll say like, for loop, it would just be, what was it, for let I equal 0, I is less than bridges dot length, I plus plus, and in here, what we're doing is we're calling log with idx, and we're passing in bridges index of I. We're passing in I itself, and we're passing in bridges. Oh, right. Cool. So yeah, so line 7 is basically a shorter way of writing lines 10 through 12. Okay. Any other questions? All right then.